Good morning, ladies and gentlemen, and happy Monday. Today is April 20th, 2020. Welcome to another episode of Mr. Vasquez's Online Math Lessons. Lesson 5, how many solutions? In this lesson, we're going to be taking a look at quadratic equations and figuring out what their solutions are with a main focus on solving by graphing. Let's take a look. We're going to get started with some quick true or false questions from 5.1. First question, 3 is the only solution to x squared minus 9 equals 0. Correct answer is false. Negative 3 would also be a solution to this equation. Sorry. Next up, a solution to x squared plus 25 equals 0 is negative 5. And false. If you plug a negative 5 into that equation, you would get positive 25. And positive 25 plus positive 25 is not 0. Bye-bye. Next up, x times x minus 7 equals 0 has two solutions. This one is true. X equals 0 and x equals 7 are both solutions to this equation. Well done. Last one, 5 and negative 7 are solutions to this equation. This one is false. Yeah, if you plugged in 5 into this equation, for example, you would get 0, not 12. And if you plugged in negative 7 into this equation, you would get 0. So this one is also false. Bye. Now let's get into 5.2, solving by graphing. Han is solving 3 equations by graphing, and they're listed there. To solve the first equation, x minus 5 times x minus 3 equals 0. He graphed y equals x minus 5 times x minus 3. Then he looked for the x-intercepts of the graph. Well, let's see exactly how that looks. Here's the graph of y equals x minus 5 times x minus 3. If we look for the x-intercepts of the graph, we get 3 and 5. Now, how does this solve the equation he was trying to answer before? Well, we know when we plug in 3, if we plugged in 5 into the equation, the y value would be 0. So these are the x values that would make the y value 0. Or in other words, these are the x values I could use to make the equation equal 0, which was the equation he was trying to answer in the first place. For the second equation, he had to rearrange the equation first. So he took the minus 1 that was on the right and he added 1 to both sides to get x minus 5 times x minus 3 plus 1 equals 0. He then graphed this equation. So let's see what that looks like. Once again, if we look for the x-intercepts of the graph, we actually only have 1. It's at 4, 0. So this equation only has one solution that will make it equal to 0. And that's when x equals 4. So I'm not going to do the last equation, but instead, I want to really talk about what the strategy is we're using here. This idea of taking an equation and graphing it and looking for the x-intercepts can be used to solve literally any equation, even if you haven't seen it before. And this is what makes the graphing technology so powerful. You can use this strategy on exponential equations, and I want to show you an example of that right now. Here is an equation 3 times 3/4 to the x power equals 1.5. Now, this is not an easy equation to solve. As a matter of fact, we have not even learned the algebraic technique that we would need to solve an equation like this. However, we can solve this equation by graphing. If we first set the equation equal to 0 by subtracting 1.5 to both sides, then graph this equation. It looks like this. And then if we look for the x-intercepts, which Desmos allows us to do, we can actually find that the solution to this original equation was when x equals 2.409. Now that is a rounded number. If you do try to plug that back into the equation, you will get an answer that's very close to 1.5. But that's really good. Without any other algebraic technique, we wouldn't have been able to find any solution. With graphing, this always works. So for the next activity, we're going to talk through finding some of these quadratic solutions. Now, graphing works great, but it's not something that we always need to do. Especially if we don't have access to Desmos or we don't have access to graphing technology, it might not be our first choice. In question number 1 here, x squared equals 121. There are two solutions to this equation. Either x equals 11 or x equals negative 11. And that's pretty easy to do by just reasoning. I wouldn't have to graph this equation to figure out exactly what the solutions are. For number 2, it's a little bit more complicated. This one I can't reason from the very beginning what my solution might be. Maybe you can, but it's not as easy. So I could see you solving this one using two different approaches. On the one hand, we could add the 31 to the other side to get x squared equals 36, and then solve from there. Or we could try this graphing method where we get it equal to 0 by adding 5 to both sides, and then graphing the equation that we have there. If you do that, we can then look for the x-intercepts of the graph, which appear at 6 and negative 6, which of course are the solutions to this equation. So the advantage of graphing to solve this quadratic is that we definitely see the two solutions. Whereas if you try to do this using the first method, you might not remember that there should be two solutions, and you might say that x equals 6 and just leave it as one solution. But with the graph, it very clearly shows us that there's two solutions to this equation. And when I'm asking for the solutions, you need to make sure you write all of the solutions. For question number 4, we're given x plus 3 times x minus 1 equals 5. To solve this one, we have to figure out what two numbers multiplied together give us 5, and figure out what value of x is going to give us those two numbers. So that's the type of reasoning way, and we don't have a really good method for figuring that out. To answer this question, the best way to go forward is to solve by graphing for now. We'll learn other techniques throughout this unit as we move forward. To solve by graphing, we're going to move the 5 to the other side by subtracting it so we can get it equal to 0, and then graph as if it said y equals that equation. Then we're going to look for the x-intercepts of the graph to find that our solutions are at negative 4 and 2. I would also encourage you to try plugging those numbers back into the equation. If you plug 2 into that equation, for example, 2 plus 3 would give you 5, 2 minus 1 would give you 1, and 5 times 1 equals 5. So we can show that it is a solution. You do the same exact thing for negative 4 as well. I want to show you one more here. X plus 1 squared equals negative 4. We can actually solve this one by reasoning as well. On the left-hand side of the equation, we see something squared. Doesn't really matter what it is, but it's some quantity squared. On the right-hand side, it says it equals negative 4. Now, just by reasoning, we can say that anything squared is always positive. Whether it's a positive number times a positive number, you get positive. If it's a negative number times a negative number, you get positive. So it's not possible to square something and get a negative result. Not on the real number lines, that is. You might be able to say right away that there's actually no solutions, no real solutions to this equation. And if we do graph this equation by adding the 4 to the other side first, getting it equal to 0, and then graphing this equation, you'll see that our graph doesn't come close to the x-axis, and therefore there's no x-intercepts. And therefore, there's no solutions to this equation. So that's also possible. And remind you that this lesson was called How Many Solutions? And we're seeing here very clearly through graphing these quadratic equations that most of the time we have two solutions, sometimes we have one solution, and sometimes we have no solutions. All three of these are possible. For the last activity, I want to talk about some very common errors that students make all the time when solving quadratic equations. Let's take a look at 5.4, number 1. Take a look at this equation. X minus 5 times x plus 1 equals 7. Now, Priya reasons that if this is true, then either x minus 5 equals 7 or x plus 1 equals 7. So the solutions to the original equation are 12 and 6. Sorry, Priya, but this reasoning just doesn't add up. She's trying to use the zero product property here. The problem is it's not equal to 0. The zero product property only works when the product is 0. And we could easily disprove Priya's reasoning by taking one of her solutions and plugging it back into the equation. For example, if we just take x equals 12 and plug it back in, you'll see that the x minus 5 does equal 7, but x plus 1 equals 13. And when I multiply 7 and 13, we get 91. We don't get 7. So these are not the solutions to the equation. If you wanted to solve this equation, at the moment, I would recommend getting it equal to 0 and graphing this quadratic to figure out where the x-intercepts are. Number 2, take a look at the equation x squared minus 10x equals 0. Diego says to solve, we can just divide each side by x to get x minus 10 equals 0. So the solution is 10. Muy bien. Mai says, I wrote the expression on the left in factored form, which gives x times x minus 10 equals 0, and ended up with two solutions, 0 and 10. Whose method do you like better? On the one hand, Diego came up with one solution, and it is correct. However, Mai came up with two solutions, and those are both correct. And as I mentioned before, when you're solving a quadratic equation, I need you to write all the solutions to the equation. So we would prefer Mai's method. And this brings up a good point. What did Diego do wrong? Well, when you divide both sides by x, you're canceling out one of your solutions. That solution that you might have been able to find is now gone. You divided it away. So you never really want to divide what you're trying to solve for to cancel it out. So that's all we have for today. If you like this video, make sure to like and subscribe. And until next time, stay safe out there.